Hello guys, welcome back to In 5 Minutes. In this presentation we are going to see pattern detector or a sequence detector using state machine. In the earlier sessions we have seen the pattern generator or the sequence generator using shift registers and the flip-flops, but now we will detect the pattern or the sequence with the help of state machine. So for that let us solve one problem and you will get the complete idea. So the question here asked is, given a pattern detector to detect 3 or more ones in consecutive order, means there is an input X through which a continuous data stream is coming and you have to detect the 3 consecutive ones or the bit stream of ones coming more than 3 consecutively. Okay, so for this we need to draw the state diagram. So the very first state is the state diagram. So for this state diagram, first of all, let us assume the state is 0, to which this is the first state or the reset state I can say. So this is the reset state through which we are going to calculate the number of ones arriving from the input X. So from input X to S0, if the input is X0, then the S0 will remain in itself and the output will be 0 because we have to detect 1. If the input is 1, it will move to the another state, that is state number 1, S1. For input 1, the output will be 0. Why? Because still the whole sequence is not detected. So at the same time what I want to do is the state and simultaneously detected sequence. I need to find it out. So for which I'll make a small table here. So for state S1, so this S1 indicates that it has detected 1. Okay, moving out further, for S1 state, if 1 is detected, now for S1 if 0 appears, then it will go to state number S0, output is 0 because the whole sequence 111 is not detected. If S1 detects 1, then it will go to the next state and the output still will be 0. Why? Because 3 ones are not detected. This is only the consecutive second one. So next state is S2. Now for S2 state, if you are in X2 state, then it indicates that you have detected 2 ones. For S2 states, let us say again the input is 0. It will return you back to the S0 state. So for 0 input, the output will be 0 once again, and if the input is 1, the output is 0. 3 ones are detected and it will move to the state number S3, and this S3 will give us the output because consecutive 3. So S3 indicates that 3 ones are detected. Okay, so it will move to S3, the output will be 0. Now for S3, if the upcoming input is 0, it will return it to S0 state and the output is 1, that is nothing but the sequence 111 is detected. Now we have to detect 3 ones or more than 3 ones. So if the next input, that is nothing but fourth input, it is 1, then what will happen? It will remain in the S3 states. The input is 1, output is also 1. That means if you are there in S3 state, that means it might have detected 3 ones or it have started detecting the more number of ones continuously. It will remain in S3 state and the output will be continuously 1. The S3 state, it will go to S0 only and only when the input is 0. That will break the stream of ones and we will return to the reset state, that is nothing but the starting of the state diagram S0. Now hence our circuit diagram is complete here. State diagram is complete. Now for this respect to state diagrams, we have 4 states. Now for these 4 states to assign, we will be required to use these 4 states, we have to assign the variables. So for these states, the assigned variables are 2, with the help of two variables we can assign the states. Okay, so here I'll make a column for state, and the next column is assigned variables. So these assigned variables are, two variables will be there. Why? Because we have 4 states. So these two variables are variable A and B, and the corresponding states are S0, S1, S2, S3, and their corresponding variables are position. S0 will be represented as 0 0, S1 as 0 1, S2 as 1 0, and S3 as 1 1. Okay, now to design this pattern generator we need to have a truth table or the state table in the case of state machine. So let us design that state table here.